and all. We are final year students of TJ College of Engineering, Department of Electronics Engineering. We are here to present our final year project, which is vacuum cleaning robot. I am Trupti Mamlekar. I will be explaining you about introduction and objectives of the project. So the main question arises is why vacuum cleaning robot. So the main reason for choosing this project is as the pandemic is going on. So when the things will goes to the normal, we need of sanitization in many places like school, colleges, railway stations with minimum or no human contact. So with that we come up with this idea. Further looking into this iBot, we came up with another research which tells us that there is a large amount of people who cannot do things without the house help. So it will be useful for them also. With this, there are various features of this iBot which are sustainable, affordable. It will be useful. It is useful with a minimum contact or no human contact, and it is reliable also. The main objectives of our projects are we want to implement this project with a cost efficient vacuum cleaning robot. In the further stages, a mechanism can be installed in the robot through which it can spray a disinfectant as vacuum cleans the area, as well as Bluetooth enabled communication with a mobile application to control the functionality. As maintaining hygiene and cleanliness plays an important role during this ongoing pandemic, this robot can be upgraded and modified according to the needs. This prototype is designed and implemented using Arduino Uno, MOSFET driver, motor driver, actuators, and ultrasonic sensors. There are few features of this advanced cleaning robot, which are auto, spot, turbo, cleaning, calm, controller, and breath piping. Next will be the working of the robot, which will be explained by Tanaya.
Hello everyone, my name is Sanaya and I'll be explaining about the next part. The general working of vacuum cleaning robots are divided into two parts. So the first one is where we consider the typical manual robots, which has been already shown in the first picture. It has various parts which include the intake port, exhaust port, an electric motor and a fan, a porous bag which collects all the dirt, and a house container which houses all the electronic components like the controller, etc. The second part is the autonomous robot. This bot contains sensing elements, a microcontroller, and motors and drivers. Uh, the basic plan of action that we have followed in our implementation of the project was first was implementing an autonomous robot. So initially we started off with implementation of a line following robot, and then we scaled it up to an autonomous robot. The second part is addition of vacuum suction capability. So in this we essentially implemented the vacuum suction capability using a fan blower, which was driven by the MOSFET driver, and we then interfaced this with the Arduino Uno. And the next part is the extension by addition of disinfecting capability. So in this, we were supposed to implement a disinfectant spraying mechanism, which would spray disinfectant in the area while simultaneously vacuum cleaning and wet wiping. So unfortunately, this was not done because of the ongoing pandemic. The next part will be explained by Tanya.
Hello everyone, my name is Tanya and I'll be throwing light on the hardware and software requirements of the robot. The hardware components of this vacuum cleaning robot include Arduino Uno, the drivers that we use, that is MOSFET and H-bridge, sensors, gear motor actuators, fan blowers, and a pair of wheels. Arduino Uno was the microcontroller that was used for the implementation of the vacuum cleaning robot. The IRF 520 MOSFET driver was used to drive the fan. The L298 edge bridge dual motor driver, it was used to control and drive the motors. And the sensors that we used were ultrasonic sensors, HCSR04, which provide up to from 2 to 400 centimeters of non-contact measurement for the target. Um, we also used the fan blower, which the basic functionality of this fan blower was to provide suction capacity so that it provided the CFM of 11.8 cubic feet per meter across the surface, that it picks up the dirt with its force and it moves it to a vacuum bag or cleaner. The dirt from this vacuum bag or container can be removed as it's detachable from time to time as and when it gets built. Now, the software, in this section, we learn about the software that was used in this robot. We used the programming environment Arduino IDE. The basic programming language that is used in this IDE are C, C++, and Java. The reason that we chose Arduino IDE was simple because it was inexpensive and it provided a coder-friendly environment. There was no need of an external burner. It is an open source IDE and it makes programming easier. And that's all about the software section. Now I'll just throw light on the modus operandi, that is how we tried to go about this project. First, we wanted to understand the working of a normal and automatic vacuum cleaner so that we could understand what the problem statement here is. Based on the parameters that we set, we implemented the hardware and software selection. Then we implemented an LFR, following which we implemented an autonomous robot, with which we wanted to achieve precise movement of this autonomous robot in household surroundings. Once we achieved this precision, we added a vacuum system and a dirt collecting bag to achieve the functionality of vacuum suction and cleaning. The next step in this project would be the 3D printing of this entire robot to form the enclosing container. This would provide robust and ruggedity to the product. The last step would be inducing Bluetooth module and application control so that we can control the robot remotely.
The next part is the working part. Here is the block diagram rightly mentioned. So there are various block diagrams that we have implemented in our project, which includes the motor driver and motors assembly. The next is the fan blower setup, which includes the fan blower as well as the fan driver, which is the MOSFET, and the sensors assembly. All of these blocks were governed by the Arduino Uno microcontroller. So we'll dive deep into the working. So here, as we know, the microcontroller, which is the Arduino Uno, it gets all the inputs from the ultrasonic sensors HCSR04. These sensors are located at 4 different sides on the robot, which is in the front side, back side, in the left hand side, and in the right hand side. So these sensors will retrieve the information about the floor and the environment around the robot and convey it back to the microcontroller. So by processing this information and processing the code which has already been installed in the Arduino Uno, the microcontroller will take a decision as to how the robot should move and avoid collision with any of the obstacles which might be present in the path. So this is the working of how this is how the robot moves. So coming to the fan setup, as the robot moves, the fan blower is also continuously working. It is continuously sucking air enough to produce force which can vacuum clean the dirt on the floor. Then this dirt is then pushed into the bag or the dirt collecting bag. So once the bag is full, we can remove the bag, we can throw all the dirt and again install it back. So then a LiPo battery can also be connected, which can essentially provide power to the entire system. And a main switch can also be provided, which will be used to switch on or switch off the entire assembly according to the user's requirement. So we'll be diving into Tinkercad for further analysis. Trupti?
So we have implemented our project in the Tinkercad software. So as we can see, we have connected 4 ultrasonic sensors to the digital pins of the Arduino. In the place of the fan blower, we have placed a motor which is available on the component list of the Tinkercad. Also connected the normal motors for the functioning of the robot. We have adjusted the distance of the obstacle from the sensor by doing this.
Yeah. So the next part is where we discuss about how the sensors retrieve the information and convey it back to the microcontroller. So if the front sensor here detects So basically, what we've considered is that in Tinkercad simulation, the minimum distance between the sensor and the obstacle to be 20 centimeters. So if it is less than 20 centimeter, then the robot will come to know that it has to change its direction to avoid any kind of collision with the obstacle. But in actual implementation, we have considered this distance to be 4 centimeters to be as accurate and as precise as possible. So coming back to the front sensor, so if the distance here, as you can see, the distance is less than 20 centimeter, which will convey to the microcontroller that it has to change the direction. So now what the microcontroller will do is that it'll make the motors move backward and then take a left turn in order to avoid any collision. So if the obstacle is in front of the back sensor, then obviously the robot has to move forward and then take a right direction to be as far as away from the obstacle. Next is the left sensor. If there's any obstacle on the left side of the board, then the left sensor will come to know, and then the left sensor would move forward. Then it'll move a bit backward, and then it'll take a right turn to stay as away from the obstacle as possible. And if the obstacle is detected by the right sensor, then it will work exactly opposite to how it worked during the left sensor. So here it will move forward first, then it will go a bit backward, and then it will take left direction and move forward as possible. So let us run it once and see as to how it works. As we can see, the distance here is less than 20 centimeters, which means that the robot is surrounded by obstacles. So in this condition, ideally speaking, the robot should stop, which is what it is doing. As you can see, the simulator is detecting that it is obstacles are on all the sides. So bot has stopped. So that is how the bot will stop, and when it stops, the fan blower will also stop working. Once it resumes working, the fan blower will also start working again. Coming back to the conclusion.
Yes. So as you could see in the video that we were successfully able to implement the precise working of the robot, and it was able to suck all the dirt that was there in its vicinity. However, owing to the pandemic and things shutting down, we could not order the things that we needed for the robot to function independently and for it to be enclosed and all the 3D printing aspect of it, which we hope to achieve as soon as things unlock and we start getting all the services that we need. Thus, to wrap it up, we can say that the robot was able to clean a smooth tile surface under ordinary conditions, and the fan was able to suck the air along with the dust and dirt particles, and thus it successfully cleaned the surface. The scope of this project in this section will be talking about what we hope to achieve further uh, with this project. That with the successful implementation of a vacuum cleaning robot, with the help of sensors and actuators based on the working algorithm and testing under various conditions, now we would like to develop a mobile app with which we can control the functionality of the robot with the help of a Bluetooth module. And furthermore, we would like to install a disinfecting mechanism which can be placed on the robot for sanitization and water-based. Thank you everyone. This was about our final year engineering project.